Alright, hello everybody, this is Miss Pi. This video is specifically I'm recording for my 6th period class because I won't have a meeting that class period, but I know I have a lot of students that are absent, so I'm putting this on Facebook, and pretty much anybody that needs it can look at it. If you were in class and needed extra to see it again, here it is. Before we get started with the worksheet today, I wanted to review some stuff with you guys. First of all, your trig formulas, doesn't matter if it's sine, cosine, tangent, cotangent, secant, or cosecant, your formulas would be written in this format. So any number that you're multiplying by your trig function, that's your a value. If inside the parentheses you have a number that's multiplied by x, that's your b value. If you're adding or subtracting from x, that's your c value. And if you have a number out here that's not part of the x, that's your d value, okay? And the way these values affect your graph is all the same no matter what type of equation it is. So whatever your key points are, and we'll go over some key points for our tangent and secant function today, those key points are going to be if you have an a value, you'll multiply each of the y values for your key points by whatever your a value is, and that's where the new transformed point is. Okay, if you have a d value, you're going to add that to your y value, and that will give you your new transformed y value. If you have a b value, you're going to divide your x value by b, and that'll give you your new transformed x value. And then if you have a c value and it's shifting to the right, you're going to add it to your x. If you're shifting to the left, you're going to subtract from your x. So now that you know all of this key features, please write it down if you need to. If you're in class, you'll probably see examples on the board by each side of the projector. Pay attention to those. They will help you as we go through this worksheet. Okay, so now let's go ahead and get started with the worksheet. Alright, so the good thing about the rest of this worksheet is that we should be able to do the whole rest of the worksheet without our calculators. Okay, and in the instructions on this page, I think this is the 3rd page of the worksheet that we started yesterday, and it tells you to find all the key points or the key features of your tangent graph and then plot those points on your grid line or on your graph and connect all the dots. Okay, so a couple things about the key features. So you can see here you have your x-intercept, or the middle of the tangent function, and then you also have this point here, which is one anchor point. This worksheet calls it an inflection point, and then this is another anchor point. Now, I will tell you that if you take a college algebra, college pre-cal class, they may call these different things, the anchor points and the inflection points. So don't get all hung up on what these things are called. Okay, so basically the lower left point, the middle point, and then the upper right point. Okay, and this is the standard graph. This is your parent function. And of course, you have your asymptote at negative pi over 2 and positive pi over 2. And this is a standard format. So these are the key features. Okay, you have your first asymptote, or your left asymptote, at negative pi over 2. Your right asymptote is at positive pi over 2. And then your lower left point, your middle point, and your upper right point. Those are all the key features, or the locations of your key points. And if you start transforming things, like tangent, or 3 times tangent x, okay, this is your a value, and by now hopefully everybody knows that the a stretches, compresses, or reflects vertically. Okay, and so what's going to happen is that anything that has to do with a y value is going to be multiplied by 3. So now this left asymptote has nothing to do with y value, so that is going to be exactly the same. It's just going to be negative pi over 2. Your right asymptote is also going to be exactly the same as the original, the pi over 2. And then here for your anchor points, your x value is going to stay the same That'll just be negative pi over 4. But your y value is going to be multiplied by 3. So the negative 1 times 3 is going to give me negative 3. Okay, and that's the same situation for all three of these points. The x values are staying the same, the y value is being multiplied by 3. Now 3 times 0 is just 0, so really the middle point's going to stay there, but then the pi over 4 is staying the same, and then 3 times 1 gives you 3. Okay, so your asymptotes are the same, and really it was just the y values that change. So what you're going to do is you'll end up with a graph that looks like that. Okay, so notice that this point here went down to negative 3, this point here went up to positive 3, and everything else stayed the same. All right, now let's look at this number 11. With this type of transformation, this is your d value. And by now, hopefully everybody knows that the d value shifts your graph up or down. And again, this is only going to affect the y values. Whoops, I can't believe I did that. There we go. So the asymptotes are going to stay exactly the same. The x value of these key points is going to be the same. The y value is going to increase by 1. So again, we're back up here to our original. The negative 1 plus 1 gives you 0. And then 0 plus 1 is going to just give you 1. And then the 1 plus 1 is going to give you a 2. Okay, so when you plot all those points on your graph and you connect the dots, you'll have something that looks like that. Now, everybody should have these already graphed. You were told to do so yesterday. So I'm not going to have this pause the video so you guys can graph them now. If you didn't get it done yesterday, you can do it for homework. Moving on. So number 12 and number 13, I'm only going to do one of these with you. You're going to have to do the other one on your own. Okay? So let's do number 12 together and you'll do 13 on your own. Now this time, this is our b value. Okay? And we know that b stretches or compresses horizontally. And we also know that to find our period length, it's going to equal pi divided by our b value. And so in this case, instead of having a period length of pi, it's going to be pi over 2. Okay, so basically we're taking our whole graph and squishing it or compressing it horizontally. Okay, so that's going to affect all of our x values. So now our asymptotes are going to be affected too. And what happens is we take our original asymptote and we're dividing it by 2. Same way we divided our period by 2, and we got the 2 from the b value. We're just going to take negative pi over 2 divided by 2 gives you pi over 4. Hold on. Let me keep track. So keep flip change. Pi over 2 divided by 2. Keep pi over 4. Flip the 2 becomes 1/2. Yep. All right. Yeah. So hopefully you guys all did the mental math on keep flip change. So yes, so what we end up doing is basically any of our numbers in the denominator get multiplied by 2. Okay, and this is only for the x values. So this pi over 4 is going to become pi over 8, or negative pi over 8. And notice your y value staying the same. 0 divided by 2 is just going to be 0. That's not going to change. And then again, the positive pi over 4 becomes pi over 8. And the right asymptote is going to be pi over 4. Okay, so those are your key points. And when you plot them on your graph, this one's going to be a little bit more difficult because it's squished so much. And yes, you can do more than one cycle, but the instructions say they just need you to do one complete cycle for the tangent function. So notice that our point is at 0, 0 here. This inflection point is at 0, 0. And then we're at pi over 8, and negative pi over 8, negative 1, and positive pi over 8, and positive 1. Okay, and then the location of our asymptotes. I'm not going to be super picky about how accurate you sketch these graphs. Just make them look like, you know, this point should definitely be between the two grid lines, not on the grid line, just between them. All right, so hopefully you can do number 13 on your own. If you need the sub to pause the video for a minute so you can work on number 13, you can, and then have her start it again. All right, this problem here is number 14. Oh, this is a shifting left and right. All right, so here's our C value. And the C, because it's a minus pi over 4, we're shifting it to the right, pi over 4 units. Okay, so because we're shifting it to the right, our X values are going to be affected, not our Y values. Okay, so here's how you're going to do this. You'll start with your asymptote, the negative pi over 2, and you've got to add the pi over 4 to it. Okay, so we add pi over 4, and most of you know that, or at least hopefully most of you remember, that when you add fractions, adding or subtracting fractions, you have to have a common denominator. So in order to make this a 4, then I have to change my 2. Give me a second. I need to change my denominator. I'm going to multiply by 2 to make that a 4. And because I multiplied the denominator by 2, I also need to multiply the numerator by 2. So I'm going to have negative 2 pi over 4 plus pi over 4, which in this case is going to give me negative pi over 4. Okay. There we go. So I have negative pi over 4 there now. So my left asymptote is going to be at negative pi over 4. Okay, now this one, negative pi over 4 plus pi over 4 is just going to give us a 0. And it's a 1. And then 0 plus pi over 4 is just pi over 4. And then pi over 4 plus pi over 4 will give you 2 pi over 4, or you can reduce that to pi over 2. Okay, and then pi over 2, oh, excuse me, positive pi over 2 plus pi over 4, very similar to the situation down here, except, let me see if I can delete that. Yep. Whoops, that's not what I wanted to delete. Okay, very similar to the situation earlier where we had the negative pi over 4, except we now have positive numbers here. And when you add those together, you end up with 3 pi over 4. Okay, there we go. So those are all of our key points. And then, let me see, how can I, where the heck is S? All right, there we go. Let me move it out of the way. Okay, so we have the standard parent function that looks like this, but we just shifted everything over, pi over 4 units to the right. So this is normally at this grid line, now it's over at the margin. The point that was at the margin is over here, and this point is moved just 1 unit, or 1 grid line over. All right, so hopefully you guys are figured out how to find or how to transform these key features. And the easiest thing to do is just keep going back to what your standard or what the parent function is, and then converting each step or each key point. All right, so now this is a little bit of a change. Instead of finding the key points and then graphing it, we have the graph, and we've got to figure out what the function's going to be. And there's some rules up at the top of your worksheet. And it says to figure out, or the figure at the right can be used to describe the effects of the constants A, B, C, D, and D on the graph of the one of the one period of functions in the form of this whole huge equation. So in other words, so our inflection points, remember back here, the inflection point, the center point, whatever our C and our D value is, that's going to be our inflection point. And the period is going to be P period equals pi over B. I know I showed you guys that yesterday. And then the asymptotes are going to be whatever our C value is, plus and minus half of our period length. Okay? And then they want you to use this information up here to figure out all this information down here. Okay? So let's go ahead and look at it. Now we need to find our A value. And A is but before we find our A value, we have to know our D value, excuse me. So if you look here, the D, your sinusoid or your middle point moved up 1, so your D value is going to be a 1. Okay? And then we need to see if we shifted it to the left or the right. Because it's our center point is still on the y-axis, then we didn't shift it left or right, so our C value is 0. But we also need to find out what the distance is from our middle point to the maximum, or to this inflection point. Okay, this y value is going to be your A, and in this case we go up 2, and normally we just go up 1. So our A value is 2. Now that I have all these points, I can just plug them into an equation. And notice, sorry, I forgot to point this out. Notice that they did give me the period this time. Okay? And so my equation is going to be my A value, which is 2, times tangent of x plus 1. And notice that this calculator, or this worksheet, does not put parentheses around the x, but hopefully most of you realize that that's going to be a parentheses around the x plus 1, unless you're like, the only time it'll be, the only time it'll be open parentheses x plus 1 and then close parentheses is if this 1 is a C value. Okay, it wasn't your C value, it was your D value. So it needs to be written like this. All right, so guys, you have problem number 16. I want you to look at this and see if you can figure it out. Have the sub pause the video for a few minutes to see if you can figure this out. See if you can just figure out what your A value is, B value, well, they already tell you your A value, and your B value, C value, and D value. Have her pause it for a few minutes, talk to your tables, see what you can come up with, and then have her start the video again. All right, let's see how you did. So a couple things. Notice that here your period was in terms of pi. This time your period length is in terms of 1. So we're going to use that information to find our B value. And we figured it out yesterday, or we talked about it yesterday. If we want to know our B value, it's just going to be our pi divided by whatever our period length is, and we said period was 1, so it would just be pi over 1, or we can say that our B value is just pi. Okay. And then notice the center of the tangent function is at the y-axis, so our C value is going to be 0. And we're not moving it up or down at all. It's at the x-axis as well. And so the D value is also 0. So the equation is going to be fairly simple. And notice how they didn't put parentheses around these two terms. And it would have, if they had put parentheses, it would have been right there. All right, let's move on. I think you guys should be able to do 17 and 18 on your own. So go ahead and give it a try. Remember the formula to find your b value. Okay, let's look at our key features of our secant function. And yes, I know that I'm going pretty fast. Sorry guys, this is a lot of material to cover. So for a secant function, again, you have key features. You have this minimum point here. And then you have two maximum points. You have one at the y-axis, and at +1 is one maximum. The next maximum's at, or excuse me, these are minimum points. This is your maximum. So you're on the y-axis at when y is +1, and you're also way over here at pi/2. And then your minimum point here is when y is -1, and your period, or excuse me, not the period length, but you're right in the middle of your cycle or your period. Okay? All right, so let's do the key features and then see what the graph looks like. Again, if you didn't graph these yesterday, you're not going to have enough time today to graph them, but you should be able to do this at home. All right, so now this is a little bit different because we're going to have our vertex or our minimum point here, then an asymptote, then our maximum point here, and then another asymptote, and then another minimum point here. Okay, so these are the standard locations, and then we just go through each transformation to see what happens to them. Now again, your a value is the number out front, and it doesn't matter what type of trig function, the a still does the same type of thing. It's still going to be a vertical or horizontal stretch, or excuse me, it's still going to be a vertical stretch, compress, or reflection. Okay, and so your x values are not going to change. You're still going to be at 1, but you'd multiply your y value here by 2. Okay, so we get one asymptote, or excuse me, my minimum at 0, 2. The asymptote here, guys, is remember, a only changes the y value, so that's going to stay the same. And this asymptote is also going to stay the same. And your vertex, your maximum point here, again, your x is staying the same. It's still going to be at pi. Your y value, instead of being -1, it'll be -2. Okay? And hopefully by now you can see that the x values are staying completely the same. The y values are just the only things changing. And to do that, you just multiply your original y value by whatever you had for a over here. All right, so we have all these key points. We plot them in our graph, and then we plot the asymptotes and connect the dots. And there's really not a lot of dots here to connect. So this one, you just kind of do a dot here and it goes up. Here you do a dot here and it's going to go down. And then over here, you point, and then it's going up again. All right. Now I will say that some of these are getting a little bit harder. So for 20, they've combined the two different transformations, but we've already done this one. Now we just need to increase it by 1 or shift it up. So we're going to, instead of starting back here and doing both of them, both transformations, the multiplying by 2 and moving it up, let's just start with these and move it up 1. So the 0, 2 becomes 0, 3. Your asymptotes don't change at all. The -2, the -2 becomes a -1. Notice I'm still adding, and some of you probably have already written down -3. It's actually -1 there. And then this 2 is going to become 3. Why do I have weird random boxes everywhere? I don't know. All right, so this one you should be able to graph it, plot your points, and that's what you've got. All right, moving on to 21. Let me see how many more of these. 22 and 23. You know what? I'm going to do 23 with you guys, and I'll let you do 21 and 22 on your own. Okay, 23 is the hardest one, and I was planning on doing 21 and 22 with you and letting you do the hardest one on your own, but I'm being nice. You're welcome. So let's go ahead and do this one. This has lots of transformations. We have our B value here, our C value, and our D value. Okay, so let's take it one part at a time. First of all, if our B value is 2, then to find, whoops, that's not what I wanted to do. To find my period length, and with secant, my period is 2 pi normally. And to see how my B transformation affects that, I'm going to do 2 pi divided by my B value, which is 2, which means that these 2's cancel out, and that my period length, instead of being 2 pi, is just going to be pi. Okay, it's just pi. So we're going to have a very short cycle. So normally our Normally our graph starts here and it ends here, but it's still going to, well, we're going to shift it too, but it's only going to be half as wide, and we're also shifting it to the right. Okay, so what you're going to do is to each x value, you're going to divide it by 2 and then add pi over 4 to it. So 0 divided by 2 is just 0, but when we add pi over 4 to it, we get pi. Or excuse me, we get pi over 4. 0 plus pi over 4 is pi over 4. I know it's super complicated math, but there you go. Now the asymptote pi over 2 divided by 2 gives us pi over 4, and then shifting it to the right, pi over 4, guess what? We're right back where we started at pi over 2. Sometimes that does happen. And then pi divided by 2 gives us pi over 2. And then shifting it to the right, pi over 4 units. It's going to be a little bit complicated. Essentially, you're going to have to get common denominators and adding your fractions, and you end up with 3 pi over 4. All right, now for the right asymptote, this is going to be fun. We're dividing this by 2, so we get 3 pi over 4, but then we're adding a pi over 4, so this time our asymptote becomes just pi, and then our last vertex, pi over 4 divided by 2, or 2 pi divided by 2 just gives me pi. When I add pi over 4 to it, we end up with, oh shoot, let me see how I can move this. There, oh my gosh. Never mind. Pretend you didn't see that. Let's get rid of that one. There we go. We end up with 5 pi over 4. Okay. So the way we got that, divided by 2 here, we were left with pi. We're adding pi over 4, get your common denominator, end up with 5 pi over 4. All right, now notice I skipped all the y values. This d value is going to affect your y value, and basically you're just shifting it up 1 unit, and so all my y values need to have a 1 added to them. So 1 plus 1 is 2. Negative 1 plus 1 is 0. And then, let me see, 1 plus 1 again. Let me see where it is 2. This box wasn't wide enough for me to put them side by side. Sorry, guys. All right. So hopefully that was problem number 23. Hopefully you can figure out what happens or what transformations and stuff that you have to do for problem 21 and 22 on your own. Let me see. Is there a way for me to graph this? I'm just going to move it up. Okay, so when you graph, once you get all your key features or key points, you can plot them on the calculator. Yeah, you can plot them on the graph and just connect the dots or set up the graph. It's pretty easy to do. Oh, pretty much the same thing we did with our tangent, but this time on looking at the graph and figuring out what our A, B, C, D, and function is. We're going to do that now with secant. Okay, and let's see. So we have all these formulas to figure out our A value, our D value, our period length, our B value, and our C value. And with this one, it's a little bit more complicated. And this is what the parent function normally looks like. Your, let me draw a line real quick. So with this, normally, this line right here, oh my gosh, not a circle, I want a line. There we go, that's a line. Excuse me. So normally this is the y-axis. Okay. And then your d value, or your sinusoid, normally that is your x-axis. Okay. And then as you change your a, b, c, and d value, that will affect where these start and whether you're stretching or compressing. Okay, so a couple things to note is a standard period length for your traditional or your parent function is just 2 pi. So if you have the same period length, like problem 24, if you have the same period length, then you have not stretched or compressed the graph horizontally, and your b value is just going to be 1. Okay. Now, to figure out your A value, remember how I said yesterday you had to go from your minimum to your maximum. So that looks like I'm at positive 4, and this one looks like I'm at negative 4. So it's obviously 8 units apart. So again, your D value is right in between. Well, right in between happens to be your x-axis. So your D value is 0. And now we just need to find our A and our C value. The distance from here to here is 4. So your A value is 4. And now we're just left with our C value. And remember how I said your function supposed to start at the y-axis and it should be going up, and if you notice we're starting at the y-axis going up, so we're not shifting it left or right this time. So our C value is 0, and then this would be our equation. Okay. Now if you look on problem 25, notice your B value, or excuse me, your period length is not 2 pi this time. Now it's 8. So we're going to have to calculate our B value. And it would just be 2 pi divided by 8. And you should be able to reduce that. So it would be 2 pi over 8 would be pi over 4. That's your period length. And again, your A value is the distance from the center to your maximum or your minimums, or from the center to the bottom, your minimum's here. And in this case, it looks like it's 4 again. So your A value is going to just be 4. And again, we're not shifting it left or right, and we're also not moving it up or down. Whoops, I just moved that whole thing. That was the wrong thing. All right, so both C and D are negative. And here's all your transformations. All right, so for 26, excuse me, I'm really tired. For 26 and 27, your period length is 8, just like it was for 25, so you should be able to find your B value pretty easily. I want you to try to find your A, B, C, and D for these, and then what the equation would look like. It should not be too hard. And then we are ready for cotangent, cosecant, and pretty much the whole process, everything that we did for tangent and secant, is going to be the same type of process for cotangent and cosecant. The difference is where the key points are. And with cotangent, you've got these 3 key points instead of your key points for the tangent. They're basically shifted over and going in the opposite direction, or a vertical reflection. Remember, yesterday we talked about how if we transform our tangent function enough, if we reflect it and shift it over, then we get the cotangent function. So this is just kind of that same basic principle. So I want you guys, you should be able to do this 28 through, let me see, 33. Hopefully you should be able to do this without a calculator. If you really need a calculator, go ahead and use it, and then see if you can figure out the key points and the asymptotes. All right. I know this is a long video. I am posting it on YouTube, so if you're in 6th period and it was going by too fast, you can watch it again. If you were absent, watch it on YouTube, and I will send reminders to everybody. All right, goodbye.